What if the most important skill for a software engineer in 2025 has nothing to do with writing code? That's the question sitting at the center of some fascinating research coming out of Google, where two software engineering researchers, Andrew and Nicole, have been studying how developers actually work in an era where artificial intelligence is deeply embedded in the craft. And what they've found is both reassuring and genuinely challenging, depending on where you're standing right now in your career. Let's start with a number that stops people in their tracks. At Google, roughly 75% of code is now written by AI. 75%. And yet, here's the paradox. Individual productivity gains from AI tools don't automatically translate into better team-level outcomes. In fact, if those gains aren't managed thoughtfully, they can actually reduce what a team produces together. More speed in one place doesn't mean more value everywhere. That tension is at the heart of everything Andrew and Nicole are exploring. So what does it look like when AI integration is actually working well? Here's something that surprised me when I first read it. The engineers who use AI the most aren't working less. They're working more. They're spending more time coding, more time ideating, more time collaborating. But the nature of that work has shifted. It's higher altitude. They're thinking about systems, about intent, about trade-offs, not handcrafting every individual line. The volume isn't lower. The elevation is higher. That phrase, higher altitude, is a really useful frame for everything else in this conversation. Because what AI is doing is pushing the meaningful engineering work upward. Execution is increasingly delegated, judgment is not, and that distinction matters enormously. One of the most practical concepts Andrew and Nicole introduce is what they call shifting left on intent. Traditionally in software development, shifting left means catching problems earlier in the process, before they become expensive. What they're proposing is doing the same thing with intent. Before an agent writes a single line of code, you need to have invested deeply in articulating what you actually want. Specification files, documented goals, explicit constraints, defined trade-offs. These aren't nice-to-haves anymore, they're the primary deliverable. They argue these files should be version controlled just like code, because in a world where agents are doing the execution, the quality of your context is the quality of your output. And this leads directly to one of the sharpest warnings in their work. They call it vibe coding, and they want you to stop doing it. Vibe coding is what happens when you casually prompt an A-I for code without precision, without structure, without guardrails. It feels productive in the moment. You get something back fast. But what you're actually doing is generating technical debt and cognitive debt at speed. The AI can make you do wrong things faster, as one of the researchers put it bluntly. Precision engineering means designing the environment your agents work in, setting rules, building skill profiles, defining what good looks like, not just firing off prompts and hoping for the best. Now let's talk about the shape of the developer who thrives in this environment. You've probably heard of the T-shaped professional. Someone with deep expertise in one area and broad familiarity across others. Andrew and Nicole argue that T-shape is now expanding in three directions at once. The horizontal bar now requires a layer of AI fluency that is simply non-negotiable. That's not optional anymore, but the wings of the T are growing too. On one side, adjacent engineering skills, security, reliability, deployment, infrastructure. On the other side, something that pure engineers have traditionally been able to ignore, adjacent non-engineering context. Business needs, user needs, the why behind the what. Because when you're the person setting intent for a system of agents, you cannot afford to be disconnected from the humans those systems serve. Speaking of agent systems, let's spend a moment on this because it's a significant mental model shift. Most people who use AI tools today think in terms of a single agent. You prompt it, it responds. But Andrew and Nicole are describing something more like orchestrating a team. In Google's own work migrating TensorFlow, they experimented with multi-agent architectures where distinct agents played distinct roles, a planner agent, an orchestrator agent, coder agents, each with their own rules and playbooks. The engineer's job in that context isn't to write code, it's to conduct the ensemble, to know which agent does what, how they hand off to each other, and how to catch it when something goes wrong. Which brings us to what they identify as the new bottleneck in software development. It's not generating code anymore. Generation is increasingly cheap and fast. The bottleneck is evaluation. How do you know the code is good? How do you verify quality at scale when the volume of output has exploded? Engineers who build robust evaluation frameworks, blending software engineering criteria with business criteria and real user context, are going to be the ones who matter most. Reviewing code line by line doesn't scale. Building systems that verify quality does. There's also a deeply human point in their research that I want to make sure lands. AI is a mirror and an amplifier. If your team has strong practices, good communication, clear tooling, AI accelerates all of that. But if your team has fragmented data, siloed knowledge, or a culture where people are afraid to admit mistakes, AI will amplify those weaknesses too. A bad system will beat a good person every time. That's a direct quote, and it's worth sitting with. No amount of AI capability fixes a broken team culture. For leaders specifically, there's a clear set of asks here. First, redefine what productivity means. If you're still measuring success by pull request throughput or lines of code merged, you're measuring the wrong things. Measure outcomes. Measure quality. Measure balanced value delivery. Second, protect learning time. During the workday, not as a side task people squeeze in at midnight. Time for tool experimentation, architectural walkthroughs, genuine skill building. Third, build psychological safety through blameless postmortems. When things go wrong, and they will, treat it as a source of systemic learning, not individual blame. Feed those learnings back into your agent context, your specification files, your shared mental models. And for individual engineers, a few concrete things worth trying right now. Before any significant feature work, write a specification file first. Treat it as the deliverable. When an A-I generates a solution, ask it to tear it down and rebuild it with documented reasoning. Not because the first answer was wrong, but because the process builds your own understanding. And before you write any code at all, pull out a whiteboard. Manually trace the architecture. Challenge your assumptions before an agent runs with them. One final thing from Andrew and Nicole that I keep coming back to. They're not describing a world where software engineers become less important. They're describing a world where software engineering becomes more important than it has ever been, and where engineers are finally being asked to operate at the level the profession has always been capable of. You aren't leaving behind the craft. You're stepping up to its highest and most impactful level. The engineers who thrive in the AI era won't be the ones who prompt the best. They'll be the ones who think the clearest.